All right, now we're going to talk about differentiating the natural log function, and hopefully you already know what a logarithm is, but here's the definition real quick. If I have the log of x base a equals b, then that can convert to exponential form as a raised to the b power equals x. So for example, if I have 2 to the third equals 8, which is true, then I can rewrite that exponential equation as log of 8 base 2 equals 3. Okay, so you may have been told that the natural log function is merely the log of x base e, but there's another way to define it. The natural log function is defined by the natural log of x equals the definite integral of 1 over t dt from 1 to x. In other words, if I graph 1 over t, which kind of looks like this, okay, and we are interested, I'm going to make this look a little nicer here. Okay, and we're going from 1 to some number x, then the area under this curve from 1 to x is equal to the natural log of x. Also remember from algebra that the natural log of a product is equal to the sum of their logs. If I have the natural log of a raised to a power, that power can come around front and turn it into n times the natural log of a. The natural log of 1 is always 0, and if I have a quotient, that is equal to the difference of the logs. Okay, so now we're ready to figure out the derivative of the natural logarithmic function. It's the derivative of the natural log of x with respect to x is 1 over x. Why? Well, remember that if the natural log of x equals the integral from 1 to x of 1 over t dt, then the derivative of that is going to be 1 over x by the second fundamental theorem of calculus. So that's where that derivative comes from. So let's apply it to a problem. The great thing about logarithms is that their properties make what looks like really hard problems into easy ones. So this is equal to the natural log of x plus 1 to the 1/2, and I can take that 1/2 and put it in front. And now I'm ready to do the derivative, so f prime of x is going to be 1/2 times 1 over whatever I'm taking the natural log of times the derivative of what I'm taking the natural log of. In this case, the derivative of x plus 1 is 1. So I end up with 1 over 2 times x plus 1. So let's use properties of logarithms to take care of this really ugly looking thing, okay? So before I do any calculus, let's split this up. So remember that the log of a product is the sum of the logs. So it's going to be the log of x plus the log of x squared plus 1 squared, and then minus the log of 2x cubed minus 1 to the 1/2. And doing a little bit more work on here, I'll bring this 2 around front and the 1/2 around front here. Whoop, I left off my natural log, didn't I? Let me put that in there. And now we're ready to take the derivative. So the derivative of the natural log of x is 1 over x. That's our basic rule. And then this is going to be 2 times 1 over x squared plus 1 times the derivative of x squared plus 1 minus 1/2 times 1 over 2x cubed minus 1 times the derivative of 2x cubed minus 1, which is 6x squared. And we'll just make this look a little nicer. That's going to be 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. And that's it. That's how you use logarithms to make easy derivatives. I've got one more example for you. Okay, so before we learned logarithmic differentiation, we would have had to use the quotient rule with the chain rule inside to do this, and it'd be doable, but it'd be really messy. But now let's take the log of both sides. Okay? And we're going to do implicit differentiation. So the derivative of the natural log of y is 1 over y, and we're doing implicit differentiation, so we're going to multiply it by y prime. Over here, well, you know what? I got ahead of myself, didn't I? Sorry about that. Let's do algebra first before we do calculus. So this is going to be the natural log of x minus 2 squared minus the natural log of x squared plus 1 to the 1/2. And that works out to twice the natural log of x minus 2 minus 1/2 times the natural log of x squared plus 1. Now we're ready to do some calculus. So the derivative of the natural log of y is 1 over y times y prime, because we're doing implicit differentiation, and the derivative of this is going to be 2 times 1 over x minus 2 minus 1/2, and the derivative of this is 1 over x squared plus 1 times the derivative of x squared plus 1, and we're almost there. 1 over y prime is 2 over x minus 2 minus, now the 1/2 and the 2's cancel, and I get x over x squared plus 1. Okay, so what is y prime? Well, y prime is y times all of this. Okay, and what is y? Well, it's this right here. So I'm going to put that deal, so that's x minus 2 squared over the square root of x squared plus 1 times all of this, 2 over x minus 2 minus x over x squared plus 1, and that is the derivative of our original function. That's called logarithmic differentiation. You take a really complicated function and you use properties of logs to break it down into simple chunks to take the derivative of.